Welcome to operating system class. We are now taking up one of a important concept regarding page replacement. So in this page replacement, the objective was there was a page table, and that page table need to be updated. And once it is going to be updated, uh, pages has to be replaced. So how a paging activity was taken up to replace the page, that was the core agenda for page replacement. So in page replacement, we have three types of replacement algorithms. First one was first out, first in, first out. Second one was optimal page replacement, and third one was the way least recently used. So these are the three main algorithms. Now let us set the page table size. The page table size, it is going to be of 3. Always the page table size is going to be 3. So if such is the case, now we are going to be assigned with an empty table, empty page table. So CPU was asking for a page called as 7. Page was not available. So what we are going to do is we are going to make it as a 7, and asterisk, it is going to represent the number of page faults. Asterisk, it is going to represent the number of page fault. So what I should do if a page fault comes, I should go to the primary memory, pick up the page and put it into the page table. So that was the core concept. So I was searching for a page 7, and page 7 was not in the page table because it is empty. Page fault has been raised. So next one, I was searching for 7. 7 was not in the page table. So 0. It was accommodated. Now one page fault is here. Next one, I was searching for 0, and 0 was not in the page table. So I am going to fit it into the page table. Again, one more page fault is going to be raised. After that, we are going to have one more item, 7, 0, 2. That means 7. I just have 7, 0, 1. 7, 0, 1 here. So we are going to have one more page fault, right? Next comes 2 here. Now, how can I see earlier the page table was empty. Now you can see the page table is full. Now, second page has to be accommodated into the page table. So, when a page must be replaced, the oldest one is going to be chosen. When the page must be replaced, the oldest is going to be chosen. That is where we are going to call it as a first in, first out algorithm. So obviously the oldest, so 7 is going to be 3 times. Therefore, 7 is going to be the oldest item. So at this case, we are going to replace the 7 with 2, 0, and 1. So second one is taken up. Next one. If you were asking for a page called as 0, and is 2 is equals to 0, is 0 is equals to 0, obviously answer was yes. So here we are going to have a fit operation. So there is no case where there is no need of a replacement of that content. Therefore, at this 0th position, there is no need for replacement of a paging activity. Next one. We are going to search for a page called as 3. So now we need to check whether 3 was in the page table or not. So in this case, comparison is going to be taken on 3 equals to 2, 3 is equals to 0, 3 is equals to 1. Obviously, comparison fails. So page fault. So page fault is going to be happen. What should I do if a page fault happen? We must use page replacement. That is first in, first out. How can I use first in, first out? When the page must be replaced, the oldest one is going to be chosen. So, who is going to be in the page table for the longer amount of time? Just now, value 2 was entered. 0 it is having 3 instances. One, it is going to have two instances, two occurrences. So at this case, now we can replace this 0th element. So obviously, we are going to interchange. So 2 followed by 3 followed by 1. So that is how we are going to manage. Next one, we need to check whether a page 0 was in a page table or not. So 0 is equals to 2, 0 is equals to 3, 0 is equals to 1. Answer is false. That means page table needs page fault. Now page fault, when a page must be replaced, the oldest one has to be chosen. So in 2, in 3, in 1, which one was oldest? So 1 is going to be the oldest element because it is going to have a number of occurrences. Therefore, now I can choose 1 here. 3. Now, take up this 0 here. Take up the 0 again. Next one. Fine. Now 4 is a page which is needed by the CPU. 4 is a page which is needed by the CPU and it is going to be searching in the page table. Is 4 is equals to 2? No. Is 4 is equals to 3? No. Is 4 is equals to 0? No. That means page fault has raised. Why page fault has raised? Because 4 is not in the page table. Okay, page fault raised. What should I do? Use page replacement algorithm. What algorithm should I use? Use first in, first out. How this page replacement in first in, first out is working? When a page must be replaced, the oldest is going to be chosen. So now in this, whether to replace 2, whether to replace 3, whether to replace 0, oldest one. So 2 is going to have 3 occurrences, 3 is going to have 2 occurrences, 0 is going to have 1 occurrence. So at this case, oldest one was 2. Therefore, we can interchange 4. We can interchange 4, 3, and 0. We can interchange the value 4 here. Next one. Now 2. Next page was 2 here. 2 equals to 4, 2 equals to 3, 2 equals to 0. Comparison is unsuccessful. That means page fault has been raised. That means page fault has been raised. Now what should I do? So I have to interchange the page. So who is going to be the longest item? 4 just now has entered. 3 is going to have 3 occurrences. 0 is going to have 2 occurrences. So obviously we can interchange 3 here. So at this case, 4. Now 2 is going to be replaced here and followed by 0. Followed by 0. So 2 is answered. Next one. 3. So 3 is equals to 4? No. 3 is equals to 2? No. 3 is equals to 0? No. Obviously, page fault is going to take now. First come, first serve. When a page must be replaced, the oldest is going to be chosen. Which is the oldest? 4 is going to have 2 occurrences. 2 is going to have just 1 occurrence. 0 is going to have 3 occurrences. So obviously, I can replace 0 here. Obviously, I can replace 0 here. So 4, 2. Now I'm going to insert the third item. Insert the third item there. So once this is done, next we are going to check for 0. Again, 0 was failed. 0 was failed. That means a page fault has occurred. Now in this, which is going to have maximum occurrences? 4 is going to have the occurrences. So I'm going to take up 0, 2, and 3. So that is up to that. Done. Next one we are going to see 3. Now you can observe that 3 was available. Therefore, we are going to call it as hit. 3 was available in the page table. Therefore, we are going to say search was successful and there is no case of page replacement. So we are not writing star here. If they are writing a star, there is a page fault. Next one. So 3, there is no replacement. Next one. Is 2 is equals to 0? No. Is 2 is equals to 2? Yes. That means search was successful. Again, there was one more hit and CPU will get the page inside the page table. You will not go for primary memory or secondary memory to pick up the page. So it is available itself, with itself. So again, in this case also, there is no question of page fault. So again, there are 2 hits. Fine. Now next one. Is 1 equals to 0? No. Is 1 equals to 2? No. Is 1 equal to 3? No. Therefore, what I should do? Now I should make a replacement. What replacement? I have to replace the things which are going to be the oldest in this item. So in this oldest item, 2 is going to be the oldest occurrence. Therefore, a page fault is going to occur. 2 is going to be replaced. That will be 0 followed by 1 followed by 3. Followed by 3. So 1 is going to be taken up. Next one. 2. 2 is equals to 0. 2 is equals to 1. 2 equals to 3. Again, there is a page fault. Now, replacement activity should happen. How is this replacement activity to happen? So, 0 is going to have 2 instances, 3 is going to have multiple instances because we are going to have bits here. That repetitive items also we need to consider. So, at this case, answer was I have to replace 3. Therefore, 0, 1, and 2. 0, 1, and 2 here. So, that is what we are going to take up. Next one, we need to see whether 0 is available here. Yes. So, there is no page fault. So, again, hit is going to be happen. So, this is going to be formed. Similarly, I am going to have 1 here. Again, 1 was formed in the page table. Therefore, it is going to be one more hit activity. One more hit activity is going to take up. Next one, we are going to have this 7. So, which one I have to replace the item? Which item I have to replace for 7? So, 0 is going to have the longest occurrences. So, therefore, we are going to say 7 followed by which is going to have the longest occurrences. So, at this case, you can see 0, 1, 2, 0, 1, 2 is going to be replaced here. So, in this, we have to replace 7 here. So, 7 followed by 0 followed by 1. We are going to get this value. So, again, it is going to be a element here, which a page fault is going to happen. So, up to now, we have page fault number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 page faults, and 11. We are going to have some page faults here. So, 7 is going to be taken up, 0 is going to be taken up, 1 is going to be taken up, 2 followed by there is an availability here. So, in this way, we are going to work out with the total number of page faults which are going to be in the first round model. So, after this, now we have taken up to 7th item. Next one, 0. So 0 was in the page table. Therefore, 0 was in the, so it is 0, 7, 1, 2 here. So now what I can do is page fault is going to be raised. The reason was I need to find an item called as 0. 0 was not available. So I am going to replace 1 here. So 7 followed by 0 followed by 2. Again, page fault is going to be raised. And finally, again I am going to search for 1. So 7 has just occurred. 0 has 7 is going to have 3 instances. 0 is going to have 2 instances. So obviously we have to replace 2 itself. So again, a page fault is going to be taken up. So we have number of page faults you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So we have some 13 number of page faults which are going to be raised. So after first in first out, now let us look into one more page for title. That is what we are going to call it as optimal page replacement. Now we are going to discuss about one more technique which we are going to call it as optimal page replacement algorithm. Optimal page replacement algorithm. Now, what was the change? What was the definition? What we are going to say was, we need to replace the page, that will not be used for the longer period of time. That will not be used for the longer period of time. So the agenda was, you need to predict the future. You need to predict the future requirement. You need to predict the future requirement. Need to predict the future requirement of the phrase. So the same task we are going to take up, and we will know how the optimal is going to work out to get a solution. So we are going to have some 20-element memory string, and now we are going to have the page table size. We are going to assume it is going to be 3. So initially page table is going to be empty. Now, what was this concept? You have to replace the page that will no longer be used after time. So, assume if I am going to have 7. Now, I can to see the prediction whether 7 will be used immediately or not. I am going to predict, and that was the scenario which was a difficult part in this was how can I make a future prediction. So, for that we need to have some algorithms which are going to be predicted so that the future requirement is going to be taken and which is going to be handled by the operating system efficiently. So, we will just start up, and thereby once page table was full, then we will have a complete understanding. So initially we are going to have an empty frame. After empty frame is going to be done, 7 is filled, page tab. Next 0 is filled, again one more page font. So we are going to have a page font. So I am going to search for 1. 1 is not in the page table. Page font is going to write, and there is an empty space. So one will come and sit, and there won't be any chances of misleading or miscommunicating of the content. Up to now, everything was fine. Next one. Second frame has to be in the page table. But second page has to be in the page table, but it is not going to be available. So we need to go for replacing. Okay, whether to replace 7, whether to replace 0, whether to replace 1. That was the condition. Whether to replace 7, whether to replace 0, whether to replace 1. So 7 it is going to be used at the last third. 0 it is going to have immediate requirement after 2, so I can't replace. 1 it is going to be used before 7. So in this case, I will not replace it with 0 and 1. I am going to replace value 2 with. So 7 it is going to be replaced with the value 2. So after that, After that, I'm going to see whether 0 was available. So I'm going to get a hit operation here. So there is no question of replacement. There is a hit operation. There is no question of replacement. Next one. I need a frame called as 3 inside the page table. So which one I have to replace? Which one I have to replace? So I can choose 2. If I am going to swap 3 with 2, again I am going to have a requirement after 2 times. Can I do 0? No, it is an immediate requirement. The next itself it is going to be immediate. So 0 I can't. Whether I can replace 1? Yeah. I am going to have 4 or 5 in between frames. Later on I am going to get 1. Therefore, optimally, the best way was I can go with interchanging with 0. So at this case, 2 followed by 0 followed by 3. So that is how the page swap is going to be handled. Okay, fine. Next I'm going to check whether 0 is in page table. Yes, 0 is in page table. So I'm going to ignore the content there. Next one, 4. Which to replace? So immediately 2 is there, I can't replace it. 3, yeah. So again, 3 requirement is there, it is going to be in the page table. Now I have a chance of 0 to replace. Therefore, I am going to replace value 2 followed by 4 followed by 3. So 4, 2, 4 and 3. Now I have a thing with the 4. Next one. I am going to have 2. So page frame 2 was found into this optimal replacement earlier. So there is no replacement here. And after that, it is going to search for 3. 3 is also going to be part of the page table. So again, 3 is available at this content. Now I need 0 to be in the page table. Now I need 0 to be in the page table, which I should replace. So first I should check whether 2 is going to be needed further. Yes, it is needed. 4, no question of 4. It is better to replace. 3 after 2 requirements. So in this, optimally, we can replace 4 because 4 is no longer needed. Because 4 is no longer needed. So now I am going to replace 0 with 4. Obviously, it is going to be 2, 0 and 3. Again, either 3 is in page table. Yes, I am going to have a tick operation. Whether 2 is in the page table. Yes, I am going to have a tick operation. So hit and hit. So next, I am going to search for 1. So is 1 equals to 2? No. Is 1 equals to 0? No. Is 1 equals to 3? No. Obviously, I need to have a page fault. I need to have a page fault. Okay. What should I do if I am going to have a page fault? I have to replace something. So how can I replace something? 2 is going to be immediate requirement. 0 is also the next immediate requirement. But 3, there is no instances of 3 there. So at this case, I can replace 3 optimally. Replace the page that will not be used for a longer period of time. Hereafter, there is no 3. Therefore, I can replace 3 here. So 2 will be there, 0 will be there. Now 1 I am going to replace it with 3 here. 1 I am going to replace it with 3 here. So that is 2, 0, 1 is going to be happen. Okay. Now 2 is equals to 2. Yes. So answer is hit. There is no question of page replacement. Okay, done. Next one. So hit here. Next I am going to see whether 0 is in the page table. 2 equals to 0, no. 0 is equals to 0, answering yes. That means again there is a hit operation. CPU, whatever page it has asked, it is in the page table. Therefore, there is no need of replacement. So it is available. So again at 0 also, there is no change or interchange operation. Okay, now 1, 2 equals to 1, no. 0 is equals to 1, no. 1 is equals to 1, yes. So obviously there is one more bit here. There is one more bit here. So there is no question of page replacement at this case. Next one. Next one. 7. Okay, is 2 equals to 7? No. Is 0 is equals to 7? No. Is 7 equals to 1? No. So definitely there is a page fault. Definitely there is a page fault. Okay, page fault came. what I have to do, I have to replace the page. Which page I have to replace? I am using optimal. If I am going to use the optimal, what is the principle? Replace the page that will not be used for the longer period of time. 701, there is no question of second page, so we can definitely replace 2 because there is no immediate requirement. 0, hey, it is just in the next position itself, I can't go with it. 2, it is in the second position itself, so 1, I can't replace it. So the best opportunity, optimal way was I can replace 2 here with 7. So answer was 7, 0, and 1. Next one. Next one was 0 is equal to 0. Yeah. Now I'm going to have one more hit operation here. Is 1 is equals to 1? Yes, I'm going to have one more hit operation. Earlier it was 50. Earlier it was 50 things inside. Now let us count the total number of page faults here. 1, 2, 3, 4, 5, 6. 7, 8, and 9. So total we are going to have 9 page faults. Total we are going to have 9 page faults. Earlier, FIFO, we are going to have 15 page faults. 15 page faults and 9 page faults it is for optimal. So hope you understand. 6 times CPU need not change. So 6 times CPU did not change the page table. So what was the advantage between first algorithm and second algorithm? The advantage was here 15 times the CPU was made to replace, use the memory unit, replace the paging activity, and trashing has been taken up. But as far as an optimal is going to be concerned, so you can see the minimization of page faults is going to happen. So that is the reason why we are going to call it as an optimal page replacement. That is, replace the page that will not be used for the longer period of time. Fine. So we have discussed 2 page replacement algorithms. So in the interest of time and interest of yourself, I will reiterate the 2 algorithms again, and therefore as for today. So this time we will not go in a very larger scale. It is for our understanding. So we will go in a moderate style for a quick recap operation. Okay. So in this formal way, we are not going to take up. We will shorten it for our understanding. So and thereby we will be taking up the 2 contents right now. I will write the string and then we can first in, first out. So 7, 0, 1, 2, 0, 3, 0, 4, 2, 3, 0, 3, 2, 1, 2, 0, 1, 7, 0, 1. So total number of strings will be 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And table size. And size of a table is equals to 3. Now we are going to have an empty thing. 7 is not there. So 7 is going to be there. Next one, we will take up 0 is not going to be there. Again, it is empty. So it is a page fault, it is a page fault. Next one, 7, 0, and 1. 3 page faults are going to be happen. Fine. Next one. I need to, so in first out, we have to replace the longer entity, right? So 7 is going to be the longer entity. So with 2, I am going to replace 7. That is 2, 0, and 1. Okay, 0 is going to be such, it is available at that item. So there is no question of page fault at this site. There is no question of page fault at this item. Next one. Next one, 3. Who is going to be a longer period? So 2 is just entered, 0 is going to have 3 occurrences, 1 is going to have 2 occurrences. So I can replace 0 here. So it is going to be 2, 3, and 1. Okay. Next I am going to search for 0. Search for 0, but 0 is not available in the page table. 1 is going to have 3 entries, so I can replace it as 2, 3, and 1. 2, 3, and 0. So replacing with the 0 element. Next one, 4. So I want to replace 4 here. So 2 is going to have 3 occurrences, 3 is going to have 2 occurrences, 0 is going to have 1 occurrence. At this case, I can replace 4. So page falls here. So 4, 3, and 0. So that is how 4 was solved. Next one, 2. 3 is going to have 3 occurrences, 0 is going to have 2 occurrences. So 4 followed by 2 followed by 0. Next one, 3. So 0 is going to have 3 instances. So 4 followed by 2 followed by 3 here. So up to here we are done. Next one, 0. Which to replace? So 4 is going to have 3 instances, 2 is going to have 2 instances, 3 is going to have 1 instance. So the longest is now, as of now, is 4. That it is going to be replaced with 3. That it is going to be replaced with 3. So that is going to be replaced with 0 here. So 0 followed by 2 followed by 3 at this time. Next one, 3. Obviously, there is a hit operation. I can't change. So there is no question of page fault. 2. It is also available in the page table. There is no question of page fault. It is going to be done later on. Now 1 has to be taken. 1 is not found in the page table. I should need to replace it. Which I should replace? Replace the page with the longer entity. So again, now you can see at this case, whether to replace 2, whether to replace 3 is going to be a challenge. So, but if I can see this 0 here, 0 has been entered between 2 and 3. Therefore, I am going to replace 1 followed by 2 followed by 3. 1 followed by 2 followed by 3. I am going to get this. I think, sorry. So I am going to have 2 from the longer occurrences. 2 I am going to have the longer occurrences. So it is 0 followed by 1 followed by 3. Before 0 itself, 2 is going to be in the origin. Therefore, we are going to say replace the longer entity. At this case, I am going to replace 2 here. Okay, fine. Next one, which I can replace. Again, 3 is going to be earlier than 0. So at this case, 0, 1 followed by 2. 0, 1 followed by 2 at this case. Next line. Now again, 0 is going to be taken up. The hit operation is going to be there. So we can't replace the page. Next one, 1. Again, it is going to be a hit operation which is inside the page table. I'm not able to replace the content. So what can I do as the last operation will be, it is going to be checking up. So 0 is going to be with the more items. So you can have 2 occurrences here, 2 occurrences. At that time also 0 is going to be there. So 7 it is going to be replacing the item. So it is going to be 7 followed by 1 followed by 2. 7, 1 and 2. So again, this is going to be a page fault here. I just mention the number of stars and just updating it. So 0. Whether 0 is going to be in the page table? No. Again, it is going to be a page fault. So which I can replace? Whether it is 1 or whether it is 2, I can replace. So you can see 1 is going to be the area between 2 here because I am going to have 2 reads and total number of reads are 1 or 4. But for 2 it is going to be 3. Therefore, I am going to replace it with 0 and 2. Again, 7, 0, and finally 1 is going to be taken up. Just now 7 and 1 are going to be happen. So 2 we can replace it. So 7, 0, 1. So now you can count the total number of page faults. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So first in, first out is going to have 15 page faults. First in, first out is going to have 15 number of page faults. Okay, you can record this. So first in, first out is going to have 15 number of page faults. Okay, now let us take the same strings and now let us iterate the optimal page replacement where we will be getting 9. How we are going to get 9? We will be just recalculating it. So after first in, first out, we will be now working on the optimal page. So in this optimal page, what we should understand was the future value has to be predicted. That is, the future requirement has to be known whether a page will be needed hereafter or not. So that is the primary way of memorizing the optimal thing. That is, replace the page. That is, replace the page that will not be used for longer period of time. For longer period of time. So we need to know the future. So that was the primary thing which will be taken care of the operating system. Okay, what are the memory strings? Memory strings, the same 20 strings we are going to take up and we iterate the process for optimal page replacement also. So we will be iterating the process for optimal also. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So page table. I'm going to have the size is equals to 3. So it is going to be an empty image. Now page font has been raised. So page font has been fine because 0 is not there. Next, one I am going to ask, 1 is not there, I am replacing, I am empty. There is an empty space, in that empty space I inserted 0. So again there is no question of questions of there is 3 page fonts which are going to be raised. 2, which have replaced. First I will check with 7 in future. In future there is 7. 7 is from the last third item. Before that there is no 7. But 0 it is immediate requirement. 1 it is also somewhere before 7. So I can replace only 7, not 0 and 1. So okay, 0 was formed in the page table. That is hit operation here. 3, okay, I have to replace it. Before, can I replace 2? It is requirement. Can I replace 0? It is immediate requirement. Can I replace 1? Yes, you can, because before 2 and 0, after 2 and 0 only 1 has to be required. So at this case, what I can do is I am going to replace 3 followed by 0 followed by 1. Next, 0 is going to search it. 0 is available at 7. So 0. It is going to be no page fault. There is going to be a hit operation. Next, I need 4. What I can replace? Can I replace 3? It is immediate requirement. Can I replace 0? It is again immediate requirement after 2 or 3 instances. But 1, it is going to have a longer time. Therefore, what I can do is I can just say 3, 0, and 4. I'm going to give the value there. 3, 0, and 4 here. So next one I'm going to take up with 2, compare. So which I can replace 3 and 0, I can say immediate. 4 is not there. Therefore, I can replace it with 3, 0 followed by 2. So 3 and 0, they are going to be the hit operations. 3 and 0 are going to be the hit operations. Again 3, again it is one more hit operation. It is one more hit operation. So 2, again one more hit operation. Next, 1. So, I'm going to predict the future. 3 is no longer needed. 0 is somewhere needed, 2 is somewhere needed, but 3 is no longer needed. So, 1 I can replace with 3. Therefore, it is going to be 1, 0, and 2. Again, 2 is found in the thing, so hit. 0 is found in the page table, hit. 1 is found in the page table, hit. Next one. I need to put the page value as 7 here. How can I put the page value as 7? Which to replace? 0 is going to have an immediate requirement, 1 is going to have the second immediate requirement, but there is no question of 2 here. So obviously, I can replace 7 with, I can replace the values as follows. That is, I can have 1 as an immediate requirement, 0 as an immediate requirement. So page 2, I'm going to replace with 7. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So total number of page faults is equals to 9. So earlier in first out, we got 15 page faults. But now in optimal replacement, we are going to have only 9. What is this indicates? Optimal itself, the word says this is the best. Therefore, optimal has a higher attribution when compared to first out. So, concluding our class, today we have taken up 2 page replacement algorithms. One we called it as first out, we worked on it. And second one, we are going to have this optimal page replacement. So in optimal, it is going to predict the future value, understand the future requirements, and operating system is going to work on it and give a best value where we are going to call it as an optimal. Fine. In tomorrow's class, we'll be working on least recently used. So that is what for all today. Thank you for joining.